Okay, so this is the second half of the special right triangles. We talked about the 45, 45, 90s in the other video. Now we're going to look at 30, 60, 90. So we talk about these special right triangles because they have special relationships between their sides. They're patterns that we can easily identify that hold true for all triangles that possess those three angles. All right triangles that are 30, 60, 90 or 45, 45, 90. So we're going to look at the 30, 60, 90. Now the first thing with the 30, 60, 90 is that it is 1/2 of an equilateral triangle. See if I can fit this on here. Goes a little off the screen. I might scoot this over a bit. It's 1/2 of an equilateral triangle. So every 30, 60, 90, you have an imaginary 60, 60, 60, which is an equilateral triangle that you can actually create from that picture. So let's look at the 30, 60, 90. When I'm doing 30, 60, 90 triangle, your 30, 60, 90 is going to look like this. Now it doesn't matter how it's oriented. You just always base your observations off of the angles and where the angles are located. So I'm going to make this 30 and this 60. Now remember, in a right triangle, because this angle is 90, the other two angles, the two acute angles in every right triangle will always be complementary. Complementary meaning add to 90. Two angles that sum to 90. You can have three angles that sum to 90, you can have five angles that sum to 90, but complementary means pair, only if it's a pair. So the two acute angles in a right triangle are a pair, and they will add to 90, so they are complementary. So just kind of FYI there. All right, when I have a 30, 60, 90 triangle, here are the relationships of the sides. The smallest side, which is across from the smallest angle, the 30, is easy to base everything off of. So whatever the smallest side is, the hypotenuse is twice as big. And then the medium side, the one across from the 60, is going to be your small side times the square root of 3. So if I was doing a ratio and writing this out as a ratio, the ratio of the sides in an a 30, 60, 90 are x to x square root of 3 to 2x. That's the ratio of the sides. But remember, you can reduce ratios as long as they have a common factor. So I'm going to reduce this ratio. What is in every one of these pieces of the ratio, every these components? X. So I'm going to divide everything out by x, and that gives me 1 to square root of 3 to 2. This is going to be your concrete ratio for every 30, 60, 90 triangle. And we can apply this by giving you just regular examples so you can see. But before we get to that, I want to show you why the 30, 60, 90 is set up the way it is, okay? Remember I told you it's half of an equilateral triangle. I'm going to draw an equilateral triangle here. Pretend like I can actually draw, by the way. And in an equilateral, remember, the angles are always 60, 60, and 60, right? And what else do we know? The characteristic it has is that all three sides are congruent. So that's why it's an equilateral. Equa meaning equal, lateral meaning sides. So I'm going to look at this particular one, and I'm going to draw an altitude from this vertex. Now remember, in an equilateral triangle, the altitude, the median, the perpendicular bisector, and the angle bisector are all the same segment because an equilateral is perfectly symmetrical. So this is the altitude, but it's also the angle bisector, which means it's going to cut this in half. So we've got 30 and 30. You can see now where your 30, 60, 90s are formed. It is also the perpendicular bisector and the median, which means this down here is a midpoint, which means these two pieces are the same, right? Okay, so let's say that I assign a value to the sides of this triangle. Let's say I say that this is 16. That means this one is 16, and that means the bottom side is 16 as well because it's equilateral. Well, we've established this is the midpoint, right? Well, if that's the midpoint and the whole thing is 16, what's each of these? 8 and 8. Look at your pattern up here. What does the pattern say? Let me move this on the camera a little bit better. The pattern says that the small side, the one across from the 30, is actually 1/2 of the hypotenuse. Here's why. The hypotenuse is going to be the same length as all the sides of the equilateral, whereas the side across from the 30 is going to be 1/2 because of what's happened when you draw this segment. I can pull this triangle and make it into two smaller 30, 60, 90s. I'm just going to take 1/2. This is 16 and this is 8, and you can see why. And then to find the altitude, you just take the small side and you multiply it by square root of 3. So there's your ratio. Small side to medium side to hypotenuse. To check and make sure that we have the correct answer, you've got 1 to square root of 3 to 2. So let's divide. So I'm going to divide all these by 8 because they have I can reduce these. So that's going to reduce to 1 to square root of 3 to 2, which is exactly what I have up here. So the small side, because of the way this is written, is always going to be 1/2 of the hypotenuse because it's 1/2 of an equilateral. And then you multiply the small side times the square root of 3 to get the medium side, the one across from the 60. Now, here's a situation where, what if I were to give you, this is 30, so that means this is the 60. So if I told you this was 7, that's the small one, what would be the hypotenuse? 14. Remember, this is an imaginary 1/2 of an equilateral, right? So this piece is 1/2. And then the shortcut, 7 square root of 3. That gives you the medium side. That's pretty simple. We'll do one more example. What if this side was 4? Then what would the hypotenuse be? The hypotenuse would be 8. And the medium side would be 4 square root of 3. So you can see how the pattern is building. Here's where some people get confused. What if I gave you a 30, 60, 90, such as this one? Here's the 30, here's the 60. And let's say I gave you the medium side, not the small one, or the hypotenuse. The hypotenuse itself would also be easy because what if I told you the hypotenuse was 20? Well, what do you know about the small side? It's 1/2, right? And then from there, 10 square root of 3. You can see how those work. But what if I gave you this one and I said this one was 6? Now I can't just double this. The doubling takes place from the small to the hypotenuse. Well, just like we did in 45, 45, 90, where you're going one way or the other. Good song by Blondie, by the way. Y'all are probably too young to remember that. So, actually it's one way or another, but who's listening anyway? So I've got 6, and I want to go to this side right here. Instead of going from small to medium, in which I multiply by square root of 3, so when I go from small to medium, I multiply by square root of 3. When I go from medium back to small, I'm going to divide by the square root of 3. Okay? So, to get this side, I'm going to divide by square root of 3. So I'm going to take 6, and I'll come down here and do it. I'm going to do 6 divided by square root of 3 to get that side. Now that's the correct answer, but it's not in the correct form. Remember, we talked about on the other video, you have to rationalize the denominator. So I have to get rid of that square root of 3. So I'm going to multiply by square root of 3 over square root of 3. 6 times square root of 3 on top, because you can't multiply outside times under. Square root of 3 times square root of 3 is square root of 9, which is just 3. And then I'm going to see, can I reduce this? And actually, yes, I can, because 6 and 3 reduces to 2. So that is the length of my side, 2 square roots of 3. Remember, I can't reduce this square root 3, the one that the radicand, the one that's underneath the radical, because it's not the same value as these out here. You can't reduce all three of these. You can only reduce together. Either they're both on the outside or they're both underneath. Can't do both together. Okay, they have to be independent. So now that I have the medium and the small, how do I get from small to hypotenuse? Well, I double it, right? I multiply it by 2. So I'm going to take 2 square root of 3, and what am I going to multiply it by? I'm going to multiply it by 2, because I have to double this to get this. Again, multiply whatever's inside together, and that's only square root of 3. And then multiply what's outside together. 2 times 2 is 4, so this would be 4 square roots of 3. So now you've actually found the two sides of the 30, 60, 90 when you're given the medium side as opposed to the small side. So make sure you pay attention to which side you're given. Always identify which side is across from which angle. If it's across from the 30, it's the smallest side, which means it's half the hypotenuse, and when you multiply it by square root of 3, you get the medium side. If it's the hypotenuse, that means it's twice as big as the one with the 30. So you find that first, and then you multiply by square root of 3 to get the medium, which is across from the 60. If you're given the medium side, which is across from the 60, when you're going from medium back to small, you divide by square root of 3, which is what we did here, and then you've got to rationalize it. We don't want radicals in the square root in the denominator, so we rationalize. Then we multiply by 2 to double it to get the hypotenuse, and that's how you do 30, 60, 90s.